Okay, we're going to be talking about factoring two special cases. And to start off, we're going to talk about factoring the perfect square trinomial. The perfect square trinomial is the result of squaring a binomial. For instance, we might square a plus b or a minus b. And the results would be similar in both cases. In the a plus b squared case, we'd have a squared plus 2ab plus b squared. In the second case, we'd have a squared minus 2ab plus b squared, with the only difference between the two cases being the sign on b, on this middle coefficient here. So we want to look for things in that form because we know that they're a perfect square trinomial and we can factor them quickly. For example, let's look at x squared plus 10x plus 25. We notice a couple of things. We notice that this here is a perfect square. We notice that this is a perfect square of x and 5. We also notice that 2 times 5 times x makes up this middle term. So that's how we know this is a perfect square trinomial, and we can factor it to x plus 5 times x plus 5 or x plus 5 squared. So the key here is a couple of things. One, recognizing the perfect square here and what its square root is. And then looking at this middle term and recognizing, okay, this middle term is the product of this square root times 2. So the square root of x squared is x. The square root of 25 is 5 times 2 makes 10x. Yep, this is a perfect square trinomial. Let's look at another example. X squared minus 12x plus 36. Okay. What's the square root of x squared? X. What's the square root of 36? 6. Is this middle term negative 2 times 6 times x? Yes, it is. So we know that this is a perfect square trinomial. In this case, it's x minus, noticing the coefficient on b here, x minus 6 times x minus 6, or x minus 6 squared. You might not always have 1 as your a coefficient. For instance, in the case of 4x squared minus 20x plus 25, okay, in this case we have to check, is this a perfect square? It is. What's the square root? 2x. Is this a perfect square? It is. What's the square root? 5. Is this middle term negative 2 times 2x times 5? It is. So this is a perfect square trinomial. What are its square roots? 2x minus 5 squared. The other special case we want to factor is this case. It's whenever we see a squared minus b squared. We call this difference of squares. And it too follows a very specific pattern. Let's look at an example. In the case x squared minus 9, notice that x squared is a perfect square and 9 is a perfect square, and we're doing subtraction in the middle. Thus, difference of squares. Okay? And what we want to do to follow the pattern for this is simply find the square root of x squared, which is x, and the square root of 9, which is 3. Not unlike our perfect square trinomial. The difference here is we're going to have different signs. One is going to be minus and one is going to be plus. And if we did FOIL on these things, watch what happens. X times x is x squared. Negative 3 times x is negative 3x. Positive 3 times x is positive 3x. Negative 3 times positive 3 is negative 9. Notice these middle terms are opposite terms, so they're going to cancel out, which is going to leave you with x squared minus 9, thus the pattern difference of squares. Let me show you another example. Here we have 9x squared minus 16. So we again have perfect squares on both sides of our subtraction sign. So we want to find the square root of 9x squared, that's simply 3x, and the square root of 16, that's 4. And we set up 2 just like that. One's going to be minus, one's going to be plus. And there you factored difference of squares. So those are the 2 special cases you want to be keeping your eye out for tonight's homework.